In this video, we'll look at solving a linear system by substitution. The linear system we're given is 3x minus 2y equals negative 39, and x plus 3y equals 31. So, those two equations, let's call them equation 1 and equation 2. In order to do substitution, you have to get a variable by itself. From any of the equations, you could get x by itself here, or x by itself here, or you could get y by itself here, or y by itself here. You have four choices. But clearly the easiest one to work with is equation 2, because the x doesn't have a coefficient. I'll start with equation 2. All I have to do is get the x by itself, and to do that in equation 2 it's the easiest. You just subtract 3y from both sides. Because when you do that, you have an x, and then 3y take away 3y, no more y's, equals, over here, 31 take away 3y. That's our new equation 2. I call it 2a. It's like equation 2 adjusted. Still equation 2, but it's been adjusted. And that's important because when you do substitution, you can't sub equation 2 back into equation 2. You have to sub equation 2 into the other equation, equation 1. So sub 2a into 1. Let's rewrite equation 1. 3x minus 2y equals negative 39. And now let's replace 2a, that's this equation, into 1. So that is, we know what x is. That's 2a. X is, let's replace it. This x is the same as, that's the 2a. Replace it by subbing it in, 31 minus 3y. See what we did there? Substitution. We solve for x and replace the x in equation 1 with 31 minus 3y. We have to rewrite the rest of the equation though. And now just solve. How do you solve? Well, you can FOIL, or in this case it's not FOIL, it's rainbow, or expand. 3 times 31, 93. 3 times negative 3y, negative 9y, minus 2y equals negative 39. Let's put the like terms together. Negative 9y, and negative 2y, that's negative 11y, but don't forget this 93. It's still there, equals negative 39. I want to solve for this y, but I got to get rid of this 93 first. Subtract 93 both sides, and you get negative 11y equals negative 39 minus 93 gives you negative 132. We're almost there. We just have to divide by whatever's in front of y, so divide both sides by negative 11. And y equals. You can put the negatives, but you'll know negative divided by negative is positive, so you can just go, what's 132 divided by 11? And we found y. Y is 12. You're not quite done though. We know what y is, but we have to find x. So we can sub y equals 12 back into one of the equations. Any one of these equations will do 1, 2, or 2a. Let's try equation 1. Just to see what we get. 3x minus 2y equals negative 39. So sub y is 12. So replace this y value with 12. Rewrite the equation. So we have 3x minus 2 times 12. Well, that's 3x minus 24. Just times that. Equals negative 39. We want to solve for x, but we can't multiply or divide before we do the add or subtract. We have to do inverse operations. So add 24 both sides, and you get 3x minus 24 and plus 24 cancel. And here we have negative 39 plus 24. You can do that in your head or in a calculator, no judgments. You get negative 15. And now how do you solve for x? Just divide both sides by what's in front of x, in this case a 3, and x equals negative 5. Therefore, the answer, or the point of intersection, that is, when we solve these two equations, what we're really doing is finding the point of intersection. So the solution, or point of intersection, is, I almost wrote of, is a point. So we write with brackets and a comma. The x is negative 5, and the y is 12. We have solved this linear system by substitution.